Welcome to the OCI Grails Quickcast, bite-sized portions of Grails productivity tips to help maximize developer productivity with the framework. Grails Quickcasts are brought to you by OCI, the home of the Core Grails development team and your source for professional support, project work, and training around the Grails framework. Grails Quickcasts are distributed in partnership with DZone, who help build knowledge and relationships to maximize your success. I have a mostly empty Grails 3 application here. I've got just a couple of things in place ahead of time, and I will point some of that out as we go along. First, I'll point out that the application has a couple of controllers in it. I've got a first controller and a second controller. They each have an alpha action and a beta action, and those actions simply render a string that indicates which controller action handled the request. And there's nothing interesting about those. Those are only here, so I've got a place to send some requests to help demonstrate some capabilities related to interceptors, which is what I really want to talk about. So the first thing I want to do here is I want to create an interceptor. And like all Grails artifacts, there's a command for creating interceptors. So the command is called create-interceptor. So I'm going to create an interceptor called demo.quickcast. And you see the path here where it was created is under grails-app/controllers/demo and then quickcast-interceptor.groovy. By default, your interceptors are created in the controllers directory, and that makes sense because interceptors are pretty closely related to controllers. If for some reason you don't like that and you want the interceptors defined in their own source directory, you can do that. You can create a directory under Grails-app called Interceptors as an example and define your interceptors there, and the framework will still find them and still configure them. They'll behave mostly the same as if they were declared under the controllers directory, and there's an exception to that I'll talk about in just a bit. So let's take a look at the default generated Quickcast interceptor. And this isn't going to be a fully comprehensive review of everything that all the capabilities that interceptors have to offer. I'm going to go through some of the basics and some interesting things and provide a sense for the kinds of things that you can do in an interceptor. So notice that there are three methods in the default generated interceptor. There's a before method, an after method, and an after view method. An interceptor is a lot like a filter, and there are three places in the request processing lifecycle where an interceptor may contribute behavior. An interceptor may insert behavior before the controller action is executed. An interceptor may contribute behavior after the controller action returns, but before the view is rendered. And an interceptor may contribute behavior after the view is rendered. And that's what these three methods correspond with. So the before method is executed before the controller action. The after method is executed after the controller action returns, but before the view is rendered. And the after view method is executed after the view is rendered. The before and after methods have a Boolean return type, where the after view method has a void return type. And the reasons for that are that the before and after methods most often will return true. And what it means for one of them to return true is that request processing should continue on as per usual. If one of these methods, the before or after method, returns false, what that indicates is that the interceptor has handled the request and any further request processing should not happen. So for example, remember that the before method is executed before the controller action gets executed. So maybe inside of the before method, we've got some logic that under certain circumstances, the before method decides that instead of control going on to the controller action, we're going to handle the request right here in the interceptor and then return false. And it's that returning false that indicates to the framework that the request has been handled and that the controller action should not be invoked. I'll demonstrate that in just a bit, but that's the reason that the after view method has a void return type and the before and after have a Boolean return type. There's no reason for the after view method to return false because view rendering is at the end of the line anyway. It wouldn't make sense for the after view method to return false to indicate that processing should not continue. Once the view is rendered, there's no more processing to happen anyway, so we're done at that point. I want to keep the example here just as simple as I can, so I'm going to eliminate the after and after view methods, which is perfectly legitimate. An interceptor may provide one, two, or all three of those methods, and depending on what the interceptor is doing, that'll dictate which of them makes the most sense. But it doesn't make sense for an interceptor to not have any of those methods. If you're not going to implement any of the methods, then there's no reason for the interceptor to exist to begin with. One of the things that an interceptor needs to express is which requests the interceptor should be applied to. And a way to do that is in the interceptor's constructor, I can invoke the match method and express something like that, right? So that says I want this interceptor to be applied to any request to the first controller. Remember that we've got two controllers. We've got a first controller and a second controller, and they each have an alpha action and a beta action. So what's expressed right now on line 7 is I only want this interceptor involved in requests to the first controller. Maybe I don't want it involved in requests to all of the actions in the first controller. Maybe I want to narrow this down a little bit and say I only want this interceptor applied to requests to the alpha action in the first controller. In addition to being able to express a simple string like that, I can do something like this. I can express a regular expression, and the regular expression can be as complicated as it needs to be. What's expressed now is that this interceptor should be applied to requests to the alpha or the beta action in the first controller. And I can do the same thing for the controller name. I could use a regular expression over there as well. So I'll keep this back to the more simple version like that. And I'll also apply this interceptor to the beta action in the second controller. So we've got a total of 4 actions, right? 2 in the first controller and 2 in the second controller. And I'm applying this interceptor to 1 action in each of those controllers. Another thing I could express here is something like this. That says I want this interceptor applied to all requests to any URI that is /foo/anything, right? So I've got flexibility in terms of expressing which requests I want this interceptor to be applied to. Let's add some code to the before method here, and I'm just going to add a println that does something like that. That's just going to be our evidence that the interceptor really is involved in a particular request. So let me move this over so I can see that console next to this terminal, and I want to open another terminal. I want to be able to see output from the application over here on the right and initiate requests from over here on the left. So let's send a request to localhost :8080/first/alpha. Right, so that's the alpha action in the first controller, and per line 7 in the interceptor should be applied to that request, and it was. We see this output over here on the right indicates that. If I send a request to the beta action in the first controller, the interceptor will not be involved, which is good. And then if I send a request to second/alpha, there should be no interceptor. And if I send a request to second/beta, the interceptor should be involved, and it is. Again, we see the output over here on the right. So all of that hopefully makes sense. It's not a great idea to use println in an interceptor for the same reasons it's not a good idea to use println in a controller or a service or any other artifact. Better idea is to do something like that. So like all of your Grails artifacts, interceptors have a log property added to them, and that log property is you don't have to do anything to initialize it or cause it to be configured. The framework will automatically configure that logger for you. And the default logging level, if I were to run the application right now and start sending requests to the app, we wouldn't see the effects of this logging unless I change the default logging config. And I've done that already here on line 25. And I don't want to spend a whole lot of time talking about logging config, but I want to point something out here. So what's happening on lines 25 and 26 is I'm configuring the logger for this particular interceptor to be set at the debug level, and I want to use the standard out appender, which is declared up above in this source file out of view right now. But what I want to point out is the logger name. So the logger name is grails.app.controllers. And then the fully qualified name of the interceptor class. If I move my interceptors out to their own source directory, like Interceptors, for example, that will affect the logger name. The logger name then would be grails.app.interceptors.demo.quickcast-interceptor. So I'll close that. Let's start our application back up, and we'll send some more requests to the app. And what we should see is basically the same behavior we had before, except instead of the interceptor passing information to println, it's passing information to log.debug. And there we go. We see the effects in the interceptor was in fact logged when I sent a request to first/alpha, and when I send a request to first/beta, there is no logging. If I send a request to second/alpha, there should be no logging. And if I send a request to second/beta, we see another piece of log output there. So that's all good. The next thing I want to demonstrate is a scenario where the before method might return false. In order to demonstrate that, I need to point out some other capabilities that interceptors have, and that is a lot of the things that you can do in a controller you can also do in an interceptor. So for example, you can refer to the params property in an interceptor, and that'll have the same value that it would have if you referred to the params property in a controller. And where that property is coming from is the grails.artifact.interceptor trait. When you author an interceptor, you don't have to express, and you shouldn't express anything like this. You don't want to express that your interceptor implements the interceptor trait. That happens automatically at compile time. So the framework will find all of your interceptors and will make them all implement the interceptor trait. You don't have to express that in your source code. It just happens. The interceptor trait defines a number of methods and properties that are all documented in the Java docs. And the interceptor trait also implements a number of other traits, including servlet attributes. And the servlet attributes trait provides methods like getRequest and getResponse. So inside of your interceptor, you can refer to request and response, and those properties will have the same value they would have in a controller, which is really convenient. The interceptor trait also implements web attributes, another trait provided by the framework. And web attributes provides a getParams method. And because of that, inside of your interceptor, you can refer to the params property, and it will be a map that includes all of the request parameters. It'll have the same value that it would have if you referred to the params property in a controller. So let's do something like this. We'll say if params.specialParam is equal to y, render a string. And then the interesting part is we want to return false here. So I've added just lines 13 through 16 there. And what line 13 is doing is checking to see if there's a request parameter called special param. And if there is a request parameter with that name and its value is the uppercase Y, then I want to handle the response here. I want to handle the request by generating a response by calling render and in this case passing a string. So this is just a really simple hello worldy kind of exercise here, but what I want to demonstrate is that under certain circumstances the interceptor can decide to handle the request itself and then return false, and that tells the framework not to continue on as it otherwise would. So in particular, if I send a request to first/alpha and don't specify a special request parameter, then we see the behavior we saw before. The logging happens over here, and we see the response includes rendered by first controller.alpha. That's coming from the first controller that we looked at earlier. If I send a request to that same controller action and provide a special param equals y request parameter, now we see different behavior. We still see the logging over here. The interceptor was still engaged. Notice that the response now is the interceptor handled the request. So under certain conditions, this interceptor decides that it can handle the request. It does that, in this case, simply by rendering a string. And then returning false is important here. That's what tells the framework that the interceptor has handled the request and there's no need to carry on. So in this case, there's no need to execute the controller action that otherwise would have been executed. So that's just really simple and really powerful stuff to take advantage of inside of an interceptor. Another interesting aspect of interceptors is all of your interceptors are automatically configured as beans in the Spring application context, and like all other beans, they're subjected to dependency injection. So if your interceptor needs a reference to a bean from the Spring application context, you can simply declare a property whose name matches the name of a bean in the application context. So for example, maybe our application has a service called helper service. If I declare a property named helper service in the interceptor, that helper service will automatically be auto-wired into the interceptor. So down here I can refer to helper service and then take advantage of whatever behavior the helper service has to offer, right? So your interceptors are subjected to dependency injection because they're automatically configured as beans in the Spring application context, and that's just another really slick and useful feature of the way interceptors are implemented in the framework. An important distinction or difference between the way that Grails 3 interceptors work and the way Grails 2 filters work is an important difference is interceptors are compile static friendly. So I can mark this class with compile static, and it will be subjected to static type checking, and which I cannot do in a Grails 2 filter. There's too much dynamic stuff going on in a Grails 2 filter. Grails 3 interceptors are compile static friendly, and that's particularly important in the context of something like an interceptor, because an interceptor might be invoked for lots and lots of requests. You might have an interceptor that is applied to all requests, so performance is particularly important, or may be particularly important in an interceptor. So the fact that they're compile static compatible is a really nice benefit over Grails 2 filters.